So today we decided to pair on, well, we can call it a spike to see if we can integrate some support for that file into the agent and server, Kubernetes agent and server. And we don't know if it will work out or not, but we decided to see what's possible and what we can do. So I guess I can share my screen and we'll start it first and share. So what we have discussed is the current idea of what we could do is user makes an interaction with the website to start a dev environment from a dev file, or maybe they want to start the VS Code editor in the browser, and it makes an interaction with GitLab API, and the desire to start an environment is persisted in the database. And then we have, let's say, agent number 10 connecting to the server, to CAS. Then it's similar to GitOps, basically. That connection from agent to server sits there and like waits for work to be done, basically. Or it's similar to GitLab Runner that's calling the API. And then CAS sees that it's agent number 10, and it goes and asks Rails periodically, hey, is there a, should I give it some work? Like, do you have work for agent number 10? And eventually there is something in the database and it tells it, yeah, here is what you should do in some form. We don't know what form that will be in, but then CAS replies to CAS processes that dev file, generates the Kubernetes resources from it, and maybe does some post-processing if we, whatever it needs to do.
Yeah, then injecting the editor, for example, like injecting the information about the ID or other things.
Yeah, and then that stuff is sent as a package to, like, of work to the agent. An agent applies it to the cluster and reports back on progress, I guess, something like that. Then that information can be put back into the database associated with this job record. I don't know what the terminology should be used here. And then on the user interface, the user can see that something is happening. This is the current status. Ideally, we are building a dashboard, and maybe we can have a special support for that kind of information, and we can show it there somehow. Yeah, so this is the high level hand wavy idea that we have at the moment. So we just trying to locate the place in the code base where that can be done. So it will be similar to GitOps because it is similar. So I think we should create a new module, and that will, I don't know. For now, let's call that file. We can rename anything here later. And so we will need the server module and the agent module. Server module, because that's the thing that will be pulling GitLab API and making the transformations. And then the agent module, because that will be the thing that applies whatever it got from the server to the cluster. So yeah, let's create, we can just copy something like API. This just contains wait, that's a better example. Module name.
Let's call it maybe remote dev.
Yeah, sure. I didn't better mind. Then we need an agent and server and RPC directories. Let's copy that from somewhere, and then yeah.
So will we need an agent directly, or like can we just use existing functionality that is perhaps in the Kubernetes API or the tunneling?
So we want it to be a separate thing because there's a high chance we will have a special requirements, special domain business logic that we will need to leave somewhere. And
even in the agent, like we will definitely have that in CAS, but you think we'll have custom logic in the agent too?
Yeah. I think it's not the same as GitOps. I think it will be different because it may need to expose extra ports. It may need to, I don't know, to do extra things.
Okay, that makes sense.
Well, that's what we are trying to understand anyway. Do we need it or not? I think we should, well, we will need it, but if not, we will delete it. So let me just clean everything up quickly. This is stuff that is specific to the thing I copied this code from. I will like delete everything here, most of the things. Will be the server, and that can be all removed. Just want to have a high level structure. This will be useful.
And just like talking about the goals, like anything as an example that accesses the Kubernetes API, like listing the namespaces. That's all we want to do, from initiated by the agent, right? To have a concrete goal, like have this module, I'm sorry, initiated by the server. Have the server like be able to list the namespaces, they get a list of namespaces back, and that will illustrate the plumbing that we need, and at least communicating to the agent, and the rest should be easier to hook up.
Yep.
To flesh it out, to do something real.
Let's delete. So let's start with the definition of the RPC, because well, we need RPC first. And there, like get like get
list namespaces, right? Just like list the namespaces on the Kubernetes that is connected to. Is that a good example?
Well, I think we can just start like doing what we need to do. Like just, I mean, list namespaces are.
Just a question.
Like we don't have the dev file operator and everything configured, right?
No, we don't. But to understand what we need, I suggest we start building what we need rather than building something similar. So I know that we can list namespaces, but we are trying to discover unknowns. That's what I think we should do. Like to discover unknown problems that we haven't considered. So if we are building something else, then maybe it's the same in structure, but we will not think about our problem. We will think about namespaces.
Right.
Just a question. The service should be removed dev, right?
No.
Remote. There was a typo. There's a typo in the directory name.
Oh. Yeah, absolutely. Thank you. Remote.
So
yep.
That's fine, and we can work either way. Like the goal Vishal and I had was just to understand this plumbing, like how we would hook it up. That's why we wanted to start with something simple that would already work, and then we could convert it to do other Kubernetes things. But however you think is appropriate is fine.
Let's call it get work. Yeah, we will rename it, but for now it's like get work to do, and then so we don't need that. It will be get work rest, and then get work response, and it will be something like that. And here we'll have we can look at GitOps actually. This is the RPC. This is a stream. Probably here we don't need a stream. We can just send an object, and that will be a request. For now we will have an empty request, and response will have its maybe similar. So response is a list of YAML objects.
Sure. That's the work we're doing. We're listing the YAML objects.
Yeah. Okay, let's just do it like this.
You were saying that was the response, right?
Yeah.
Yeah, I mean, however we communicate the outcome of the Kubernetes operation, whatever the way to do that is, success or error or failure.
So this is an API that the agent will call on CAS.
Okay, I got it.
And this is the reply that CAS sends back to the agent, and the agent should provision that.
So the agent is going to be polling this.
It's going to be like long polling, opening the request, waiting for a reply. If CAS doesn't have anything to say, it doesn't reply. Then once it has something, it replies.
Okay.
So that we don't like call all the time. So that's probably how we want it to look. And then we should plug this into here and be removed. And this should be, and we need, now we don't need that as well. We can remove that. Awesome. Okay, let's plug this into the proto generator. I think it's here. Yes. And this goes after. I'm just trying to keep them sorted.
Get work, right? Do you have to change the other all extract to generated? Got it.
Yeah, I'm just plugging it
into
into the build so that it generates, so that the build generates the proto definitions, and it did. Here we have that landing for get work request and blah 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 blah. And
what was the make command you ran? Make gazelle?
Regenerate proto.
Regenerate proto.
Yep. So we have our RPC definition, quite simple, and now we have. Let's start with the server. Let's clean this up. It's a copy from that. Well, and then we don't need anything here, I think. And anything here. We should start replacing this so that it doesn't import another package. And this will be exposed on the register agent. No, this is agent server. We should register it on the agent server. Now, how do I do that? I don't remember. I think it's RPC, not this RPC. RPC. We need the RPC that we have just generated.
So this is registering the server RPC endpoint for that the agent can connect to.
Remove that server. That's what we want. Big agent server, and the implementation will be the implementation will be here. We'll create this thing, and I like it to be in a separate file. It can be consistent with other modules. So we'll move here, and this needs to unimplemented remote web server. That's the generated thing as well. Comes from this file.
Did you mean to pick unsafe or unimplemented?
Oh, thank you. Why? What is this unsafe thing? I have no idea.
Don't look at it. It's not safe.
Okay. So remote. That's the thing we need to implement.
So that is just like a placeholder until we have some implementation that fulfills the
Yeah. Well,
the type signature and contract, or
this is the method that gRPC will call. When this,
I mean the unimplemented dev server in the struct, like it has to contain something.
Yeah, it just has that unimplemented, and gRPC, since some version, checks that you have it embedded. It will not work.
Okay.
It will return an error if you don't have it. Cool. Let's just return that we don't have anything for now. Cool. That's our server. It's scaffolding for it, and we registered with this gRPC server. It's given to the module from the outer program, and this is the thing that the agent connects to. And so this is the thing that the agent will be calling. And basically, your business logic goes here. The one that lives on
the agent. What is the thing the agent will be calling? The agent server.
This function. This
okay,
RPC.
right.
This is the handler of that RPC that the agent will be calling. From the agent module. Okay, and if we need any parameters for the server, they go here and they can be put here, and that's it. And the module is empty, doesn't need to do anything. That's it. And this is done. This is, well, I mean, scaffolding is done. And
so the part that I'm still missing is how will something external to the server, like we can fake it out, just pass from the command line, add another positional parameter to CAS that it's like -- foo, and then it takes a value bar. Like how would we use that? Eventually that will be a listener endpoint from the monolith, the monolith, or maybe a JavaScript client calling this, but how do we use that to trigger something to happen here?
now, for now, you can hard code something here and just return a fixed.
Right, but I'm looking to learn the plumbing of how will we hook up that, for example, an API endpoint to trigger this every time that RPC endpoint that the server exposes is called. It will make something happen here to pass information to make the agent.
You mean invoke it from the agent side?
No.
from the server
Yeah,
side.
that's the architecture. Like
Yeah,
we're
yep.
we're gonna say here here's a def file YAML, right? We're gonna pass it to some endpoint, a gRPC endpoint that the server exposes, and
well,
do the work with this, which is
yep.
transform that and run it as the operator. How do you say it on Kubernetes, be the agent?
Well, you can CAS exposes an gRPC API to Rails, but
Right, which the gem is a wrapper around,
we
right?
can yes. So we can
So
call
it would be like
but
the monolith calling the gem like.
yeah, but that's not the approach that we want. We want, like, in the end, I think we want the opposite, right? CAS, like, asking Rails for something. But so to play with it, I think we can just hard code
I
the
don't
dev file
understand
here.
that. Like how you mean CAS will be calling Rails for.
So it's similar to GitOps, where agent connects to CAS, and then CAS starts polling GitHub in case of GitOps, but in case of remote dev, this place will have a loop that will be polling Rails for can hear you. You're muted.
Sorry, I hit mute. Like we have to do polling. There's nothing in this architecture that lets us say we respond to an external event that we listen to via the server's API, external RPC API.
So the thing is, there are multiple CAS instances. We run 9 in production right now, but it will be more and more and more. So when you make a call from GitLab, you like which one do you call, right?
I assume they were behind, Workhorse or some load balancer or something in it.
Even if it's behind the load balancer, even if it's behind the load balancer, which I think it actually is for that RPC. So Rails talks to some load balancer, Google Cloud load balancer, for that internal port for gRPC API. But again, the request lands on some replica, and the agent may be connected to another replica. So you
okay, I get it. So there's no.
And that's one problem. Another problem is that the agent may not be connected right now in this second because they have network maintenance, or maybe they're restarting it because they're upgrading it, or 1,000 other reasons. So your request will time out.
And there's no
fail,
persistence
something.
here. So okay,
exactly.
now I get it. That's why you have to have a polling architecture.
Yeah, there is no persistence in CAS, but there is persistence in Rails. So we want to.
So Vishal and I were looking for something that didn't exist. That's why we didn't find it.
So I understand that polling is not the best mechanism, and we have this problem with GitOps, and we want to solve it with. We have an issue for that. There is a notification mechanism when there is a commit in, GitLab commits a commit, like persists a commit. I think it pushes a notification through some Rails mechanism.
Or
we want to hook into it. So for that, we may also want to hook into something like this.
And what I was imagining, like we have Action Cable, but there's any cable. Action Cable supports websites, but any cable supports RPC connections as well. So it's like some sort of registry that, okay, here's a registry of CAS servers. I'm going to open Action Cable connection to it from, the monolith, just like we do for Action Cable connections to the web clients, and say, whenever this event happens, then I will invoke a call on this RPC via any cable. I see there's many architectural components that we don't have to make that happen, but ideally that's how it would work.
Ideally, yes, we need some sort of mechanism, central mechanism to dispatch notifications. But also notification can be missed because whatever, and polling is the second mechanism that will catch it.
Right, that's
some point.
assuming, a guaranteed delivery, queue somewhere that is on the other end, right? Redis
Yeah.
or whatever.
Yep. So for now, we can just have a look that polls the server.
It
And
works. It does the same thing. It's a lot simpler.
This is, as you see, this is super similar. This is like get object to synchronize for GitOps. And
right. And we were looking at this, and then, there's just the poll loop, and that's what it does. And then in there, it calls the hook to the
yep, and
the agent.
comes this is the signature doesn't match because this is a streaming response, and we have a just unary RPC. I think that's how it's called, unary RPC. That. And this is the poll configuration. And why is it not important? And for poly, something like this. And here we can, I don't know, let's just, define this, something like that, and then this can be timeout. If this got tired of polling, we don't need to return an error actually in this case, but also no response. Otherwise, return what we want to return. And if there's no error, but that can happen actually. Or maybe, no, actually, in this case, we return that response. That's the right thing. And here we are supposed to fill the response or return an error, basically. And for return, well, we will need that to poll GitLab. Okay, and we also need that polling configuration.
So where did GitOps just pulls Gitly, but there's other places in here that they query Redis for information instead.
Sorry, what was that again?
So with the GitOps example, you're pulling Gitly, but we're not going to have our data in a repository. We need to put it somewhere, either the relational database or Redis. I thought I saw some of the other modules that connect to Redis. Is there an example of that?
Yeah. But I mean, Redis.
But we can finish wiring up the agent stuff first.
Yeah, like I just want to provide scaffolding here.
Or GitLab or the REST API, anything.
Well, yes. Something like that. And this will be needed later. For now, let's return. Once you're done, return done. This needs to be filled from in the factory here. Then let's look at the agent. So we have it doesn't use the internal server. Okay, module, and then server doesn't need a server. Yes, doesn't. What we do need here is how a worker, maybe that's how we can call it. The thing that would, well, we can just call it here for now. But yeah, I think it's better to separate it and like
So what is the
it's the thing that will
responsibility of the
be,
worker?
and that's
The thing that is calling the Kubernetes API?
its job is to establish that it's super similar to GitOps. Actually, this is the thing. So it holds various things, and then when it runs, it starts a pipeline of three things. First thing is watching the connects to the server, tries to get data back. Then the second stage decodes the data it got, and then third stage applies it to the cluster.
Right, we saw this. And so the watching is just a blocking call, and whenever
Yeah.
that poll returns something is when it will be invoked.
Here we wrap the gRPC call in a helper that does various things, but in our case, we don't need any of that. This is
So the watcher is implemented as a poll under the covers as well from the agent side in that right there on line 50.
No, it's, well,
Or
I think, oh, okay, yes, actually, well, yes and no. I mean, yes, because there is a loop around it, but also no, because each thing is kind of a long poll, so it connects and waits for a reply. It only retries when there's a end of stream.
so it's a long,
so it's a long poll, yeah, not just like polling.
a poll with a blocking call in the middle of in each iteration.
Yep. So we need the same thing, but much simpler because this RPC for GitOps is more complex. It chunks the response into multiple pieces because there may be a lot of files and files can be big, so it cuts them into pieces. But we don't need any of that. It's all unnecessary here. So we all have.
Could I ask another question?
Yeah.
So the implementation of the polling in the server RPC endpoint. You check the error there, and there were the three cases that you could return from. What is making this block? Like, what is the poll waiting on?
Here?
On the server side, in the RPC endpoint, the poll that we're doing there.
In GitOps or in this?
In our new one, in the mock server.go.
So
yeah, the line 20, like what is that poll like block? What causes it to iterate or block under the covers in our case?
So this poll blocks when this function returns with like continue. So this configuration, it contains information about back off. So if there are errors, it slows down. And then if there are no errors and we return continue, it continues after waiting for the interval. So,
okay, and so in a successful response, the REST API will return no work to do. Like that's where it will be implemented, and then it will just
exactly.
That will be continued.
Yeah, if like no work to do, then this will be
okay, got it.
Else like send the work back, which is the REST equals that thing, and then there's a field, and then return done. That's the logic that we use here.
Perfect. I think
So,
that's starting to tie it together. That's at least something for us to start building on. And
Yeah.
as you said, we need to definitely write up this architecture that we came up with last night.
mhm. Something like that. What's the name of the field data? YAML. Yeah.
Like a
Right.
dev workspace YAML, the thing that we've already processed and that what we need to,
Oh yes,
which
actually,
may happen on the monolith side or
right.
could
So
happen here, whichever.
what says the file generate YAML, and yeah, that's the scaffolding.
Well, the reason that the processing has to happen here is because the libraries we're going to use to do the processing are ready to go. So
Mhm.
that can happen on the rail side. It happens
Yep.
on the server.
So this is the worker, and then we need RPC. Let's say client RPC. Yep. No. How is it called? It remote dev. Remote client. We'll have basically for loop. And yeah, here we'll do client get work context. Rest options. Well, we can just whatever log it or something. Handle it anyway, and it's also work. Apply to master. Something like that. And then if context was cancelled, then we need to exit from the loop.
So this run is going to get invoked from where?
It will be once we invoke it from the module, and let's say so. Something like that maybe. So you can also feed configuration into it if we need configuration. We probably need configuration, but for now we don't. So it just works like this. And then we need to populate it, and we can do it here in the factory. It needs so worker is our worker, and the worker needs the client, and client will be new the client, and this is the config CAS connection. Something like this. This is the connection to CAS that is set up by the outer program. It's given to the module. You don't need to worry about how it works. It just works. That's it. You just need to implement it, the worker, like, and you can look at how it's implemented in GitOps. This apply job.
And the workers, that is the work that will be done on the server. That's part of that. Is that right?
This worker is in the agent. It's the thing that applies the manifests.
Okay, that will handle the talking to the Kubernetes API.
Yes. Yes.
Is there an example of that? Is that somewhere in the
Yes.
Kubernetes API?
Yes. In GitOps, in manifest, there are chart ops for Helm support and manifest ops for plain manifest, and you can look at this worker to apply.
Those workers.
Like 1, 2, 3, the stages of that pipeline, which is decodes and applies. So this is the apply stage and apply job. That's how it applies. So applier is a field. You can see how it's constructed in the factory here. Yeah, it's given the client to the Kubernetes basically, and inventory client. Yeah, just probably do the same thing. Yeah,
we would make our own a new client, or
yeah, it should be separate. It should be fully separate, and then yeah, just you got the work here, the manifests. You need to parse them, probably similar to what this decode does, and then you need to apply them, which is apply run. You give it the objects to apply, and then apply options, how to apply them, and then you need to handle the events, like look for. Well, you will see. It's a stream of events, and they have types like what's happening, you know. And then eventually everything's fine, and that's it. You're done for this work item. And then you can pick up the next one. And another thing to think about is that
so the applier is what abstracts the Kubernetes API interface.
Yes, this comes from the CLI utils library from the SIG CLI, special interest group for CLI from Kubernetes. And it's what we use to apply manifests to the cluster. It does a lot of things there. Ordering, keeping track of what has been applied, and then what on the next iteration needs to be removed because it has been deleted from the desired set of objects, and have many other things. So yeah.
All right, we got through it. That was a lot of information.
Something like that.
Well, we can watch this video very carefully multiple times. Yeah, push this to a branch and then we can take it from here. Just drop the name of the branch in Slack on the remote dev channel. Yes, it's very complex, but it does a lot of stuff, a lot of very necessary things.
Okay, done.
Perfect. Really appreciate your help. Okay.
Cool. Well, we actually are out of time for this meeting.
Right. Perfect timing.
Thank you to everybody who watched.